Sulfur dyes are the most commonly used dyes manufactured for cotton in terms of volume. They are cheap, generally have good wash-fastness, and are easy to apply. Sulfur dyes are predominantly black, brown, and dark blue. Red sulfur dyes are unknown, although a pink or lighter scarlet color is available. Production, past and present. The forerunner of sulfur dyes is attributed to cacao de Laval, which is prepared by treating wood products with sulfide sources. Subsequently, the so-called Vidal blacks were produced by reactions of various aniline derivatives with sulfur. These experiments demonstrated that deeply colored materials could be readily produced by combining aromatic compounds and sulfur sources. The most important member of the class is Sulfur Black 1. It is produced by the reaction of 2,4-dinitrophenol and sodium sulfide in hot water. Like many sulfur dyes, details on the chemical reactions are poorly understood. It is accepted that the sulfide reduces the nitro groups to aniline derivatives, which are thought to form indophenol-containing intermediates that are further cross-linked by reaction with sulfur. The result are insoluble, high molecular weight species. Sulfur Black 1 is imperfectly understood, and the material is probably heterogeneous. It is speculated to be a polymer consisting of thianthrene and phenethiazine subunits. The so-called sulfur Black dyes are produced from 1,4-diaminobenzene and diaminotoluene derivatives. These dyes are proposed to consist of polymers with benzothiazole subunits. Members of the sulfur Black dyes class are sulfur orange 1, sulfur brown 21, and sulfur green 12. Application method. Sulfur dyes are water-insoluble. In the presence of a reducing agent and at alkali pHs at elevated temperature of around 80 degrees Celsius, the dye particles disintegrate, which then becomes water-soluble and hence can be absorbed by the fabric. Sodium sulfide or sodium hydrosulfide are suitable reducing agents. Common salt facilitates the absorption. After the fabric is removed from the dye solution, it is allowed to stand in air whereupon the dye is regenerated by oxidation. The regenerated parent dye is insoluble in water. Oxidation can also be effected in air by hydrogen peroxide or sodium bromate in a mildly acidic solution. The low water solubility is the basis of the good wash-fastness of these dyed fabrics. These dyes have good all-round fastness except to chlorine bleach. Because the dye is water-insoluble, it will not bleed when washed in water and will not stain other clothes. The dye, however, may have poor fastness to rubbing. The dyes are bleached by hypochlorite bleach. Environmental issues. Due to the highly polluting nature of the dye bath effluent, sulfur dyes are being slowly phased out in the West, but they are used on a large scale in China. Recent advances in dyeing technologies have allowed the substitution of toxic sulfide-reducing agents. Glucose in basic solution is now used, and both low sulfide and zero sulfide products are available. Future developments in the field of reducing dye levels by means of electrochemical processes are promising.